Is it possible that you raise one irrational number to another irrational number and you get back a rational number? The answer is yes. And we're going to prove this. It's called an existence proof. I'm going to show that there does exist a number that, an irrational number, that when you raise it to another irrational number, you get back a rational. Not going to show you what those two numbers are. Not going to show you what these two numbers are, but I'm going to show that they exist. Okay. So consider the square root of 2 raised to the square root of 2. So there is an irrational number raised to an irrational number. Now we have two cases. Case 1 and case 2. Case 1 is the square root of 2 raised to the square root of 2 is rational. And case 2 is the square root of 2 raised to the square root of 2 is irrational. Now, in case 1, if the square root of 2 raised to the square root of 2 is rational, we are done. We are done. Now, I don't know if I said this, but either the square root of 2 raised to the square root of 2 is rational or it's irrational. Now, if it's rational, we are done, and that's it. Now, if it's irrational, so now this number is irrational. Now, consider this number, which we are assuming is irrational, raised to an irrational number. Square root of 2 is irrational. So we have this irrational number raised to the square root of 2, but you multiply those powers. This is square root of 2 raised to the square root of 2 times the square root of 2, and square root of 2 times square root of 2 is 2, and the square root of 2 squared equals 2, which is rational. Okay, and the proof is done because either this number is rational or it is irrational. If this number is rational, then we're done, because I wanted to show that an irrational number raised to an irrational number could be rational. Okay, but maybe that's not the case. But if it is, we just showed irrational to the irrational is rational. Okay, now, because we're assuming that this here is rational. Alternatively, this may be irrational. So I took this irrational number, square root of 2 raised to the square root of 2, and I raise it to an irrational number, and I do get back rational. So we conclude that there are two irrational numbers where I raise one to the other, and I get a rational number. Actually, I said that I can't show you the numbers. That's actually not true. Either that's one of the numbers and that's the other number, or this is one of the numbers and that's the other number. Okay, so it's one of those two. One of those two is an example of an irrational number raised to another irrational number, giving a rational number. One of these two have to be rational. If it's this one, we're done. Otherwise, that means this is rational, and when I raise it to the square root of 2, whether this is rational or irrational, when I raise it to the square root of 2, I get back 2, which is rational. And that completes the existence